Welcome everyone. Here is the topic we will discuss it digital simulation of the root locus plot for the desired time response of the higher order system. Here it is a group member Bharat Chavan, Vaishya Darunte, Samiksha Gadikar and Pragati Gaikwad. The aim of the experiment it is to obtain the root locus by the using the MATLAB simulation for the unity feedback system with open loop transfer functions. Here it is application. The main application it is the root locus also helps in the deciding the stability of the control system. The root locus of the system whose open loop transfer function is g of s equal to k upon s into s plus 2 into s plus 4, where number of poles n equal to 3 and number of 0 em equal to 0. Poles are marked by cross mark and 0 with the small circles. This is the S plane. Imaginary axis pole 0 plots and root locus on the real axis. Here it is the poles are drawn on the graph. To find out the root locus on the real axis, this is the second step. If the count is odd, then the root locus is there. Total number of poles are and zeros on the right side of the test point. Third step is to find the asymptotes and the centroids. Centroid equal to minus 2. It is represented. It is drawn as the center where we can get the points of asymptotes.
So the fourth point is how to find the breakaway points. So here the transfer function equation is given. That is g of s by r of s is equals to g of s upon 1 plus g of s into h of s. The g of s is given and h of s is unity feedback. So the equation for this transfer function is k upon k plus s into s plus 2 into s plus 4. After that we will find the characteristics equation from the denominator of the transfer function. So the characteristics equation for this system is k plus s into s plus 2 into s plus 4 is equal to 0. After that we will get the polynomial equation. The polynomial equation is s cube plus 6s square plus 8s plus k is equal to 0. Then we will find the value of k. K is equals to minus s cube plus 6s square plus 8s. Then we will differentiate that equation and we will get the polynomial equation, that is minus 3 square minus 12s is minus 8 is equal to 0. When we put this equation into the calculator, we will get the two value, that is s is equals to minus 0.845 and minus 3.154. When we put this value into this equation, we will get the value of k. K is equals to 3.08, which is the root locus equation. And when we put the value of s is equals to minus 3.154, then we will get the value of k is equals to minus 3.08. And on another slide there is the fifth point, in that how to find the angle of departures and arrival. There is the number of complex poles and zeros, so number of angle of departures are arrival. In the sixth point, how to find the crossing points of the imaginary axis. The characteristics equation is given. The characteristics equation is k plus s into s plus 2 into s plus 4 is equal to 0. So when we solve this equation, we will get the s cube plus 6s square plus 8s plus k is equal to 0. When we put the value of s is equals to j omega, we will get the equation minus j omega cube minus 6 omega square plus 8 j omega plus k is equal to 0. J omega cube is nothing but j square into j. After that we will get the two parts, that is imaginary parts and real part. The imaginary parts is omega is equals to plus or minus 2.8 and the real part is k is equals to 48. The cutting points are plus 2.8 and minus 2.8. There is the breakaway point which is minus 0.85. From that the line will be diverged towards the plus j 2.8 and minus j 2.8, and the another graph we will get when the line will be diverged towards both cutting point. After that there is the apparatus required for this system. The apparatus required for these systems are personal computer, MATLAB software, and after that there is the program. In that the numerator is 1 and denominator is 1680. That's how when the transfer function is g of s is equals to k upon s cube plus 6s square plus 8s. So the numerator for this equation is 1 and the denominator is 1, 6, 8 and 0. So the system is equals to transfer function into numerator comma denominator. So the rlocus system is a command for this program, and rlocus find system is also command for this program.
Now we will see the output of program in MATLAB and implement the root locus for the given transfer function. So first we'll take num, which is numerator, is equals to 1, den is denominator, and here we will take the coefficients of denominator, that is the coefficient of s cube, s square and s. Sys is any variable and tf is the predefined transfer function. R locus sys is used for implementing the root locus. Now we'll take rloc find sys to identify the range of k value and run the program. See the command window. This is the output of program, which is the continuous time transfer function. Now we need to select the point in the graphics window. The imaginary crossing point is this one, where we need to find the value of k. Cross check with the command window. The real part is almost 0 and the imaginary part is 2.85 I and the gain is 48. Theoretically also we get the same value of gain. So if the value of k is 48, the system is stable, and if the value of k is greater than 48, the system is unstable.
Here there are three poles. You can check the pole location is -4 and the gain is 0. If we increase the k value, then the pole location is also changes, and this is called as root locus. Here you can see the pole location is also changes. The pole is -4. Here there is a next another pole. The gain is 0 and the pole is -2. Here it is a horizon pole. The pole is 0 and the gain is also 0. Now if we increase the pole value, the pole location will changes. Based on it will move. On moving it will cross imaginary axis. So it entering into the right half of S plane and the system will become unstable. At this point the system is stable. So if we cross this imaginary axis, then it will become unstable. And in right half of the S plane, it is a stable system. Here you can see there are three colors. That is, this is a 3 infinite locuses. One is -4, it travels towards negative. This one, another is -2, it travels. Here it is a breakaway point. After crossing this breakaway point, it travels downward in imaginary axis. And one, here you can see that. And one is -4, it travels towards the infinity. So based on observing this, we can design our system.
After then, after that, the simulation result is given. The simulation result is already explained. So the result for the system is root locus plot of the unity feedback system with OLTF G of S, which is the transfer function equation, is obtained by the MATLAB simulation. For the simulation, it was found that the four equation which is given in this result, this we already find in this system. Thank you.